Alright, so I'm just going to go over some of the stuff that we're doing over here with search and discovery. So discovery is a client, is an interface to external searching technologies. Right now we're using Elasticsearch and CouchDB. Its responsibility is to aggregate and manage the search results across multiple technologies. And it supports navigation across the association graph for resources associations. Indexes are repositories for searchable documents. That is it in a nutshell. Each index is optimized for a specific purpose, so we'll have like devices index. They have scripts that improve the mapping and the indexing for device resources, one for events, and a few others. Indexes are not isolated to a single technology. They can be one index can be CouchDB, one index could be Elasticsearch. Catalogs and views. Catalogs are just a group of indexes. It keeps track of things that they have in common and aggregates what you could be searching for and the metadata along with it. And views are essentially just a group of catalogs with searchable options so that the results of querying against a catalog are displayed or presented differently. So this kind of goes through the flow of how a query is made. A client makes a query to discovery using either the language or a query object, which I'll go into in a second. Discovery then parses the string and forms a query object. It then gets passed to the request method, which determines if it's a tier 2 or a tier 1 search, whereas tier 1 is a simple singular request only going to one technology, and tier 2 goes across multiple technologies, or it's multiple requests that have to be aggregated. Once the tier is determined, the query is then passed to the query request, where it goes to various query methods, each specializing in what type of query it is. And if it's a tier 2 at the very end, all of the results are aggregated together using set operations, union and intersection. Then the result is passed back to the client. Clients may use either text searching or a query object as illustrated. So the search string is parsed and tokenized, and each token is broken down, and a JSON or a dictionary is formed from each token. Discovery also supports geospatial searching. Right now we have two query types that are supported: geospatial distance, where it locates documents with a point within the radius of an origin specified in the query, or a bounding box. Term searching supports wildcards. Term searching is also not analyzed and it's not tokenized the way the documents and fields are indexed. So exact term matching is not supported, I should say. It's complicated. Basically, things like phrase searching will not work here. Exact matches will. And of course, the wildcard kind of makes up for the other things. Range searching. Documents with numeric fields are indexed to support range searching. Association traversal. Discovery uses a breadth-first search algorithm to traverse an association graph and return the entire graph as part of the query. Typically, it's used when aggregating the results of this with other search queries. Collections are just bins of resources. This is an example of a bounding box search. So there we have a resource at that location. The search string is crafted using those points, and discovery.parse is called on the search string, and the results are returned back. Here we're adding more constraints to the search. We're using the AND. We're adding a temporal offset, so now we have one more dimension added to the search, and an additional dimension with altitude. So now it's a four-dimensional search. Two-dimensional geometry, one for altitude and one for time. So term searches. Search field is string with wildcard support from index. Range queries. Search field values from X to Y from index, where the range of the values is closed X, open Y. Associative queries. Using the keyword belongs to, you can have the association traversal begin, which will by itself return the entire association graph. Typically we will aggregate this with other search queries to determine if that resource belongs to another resource. You can also limit the depth of the traversal using the limit keyword. Use the keyword in to determine if it belongs in a collection. Again, this is typically used when aggregating with another query. Geospatial distance searching. So search field geodistance, the distance, space, the units from, a lat, long, and then the index. Bounding box, very similar. Search field geo box, top left lat lon, bottom right lat lon from index. So joining the queries, it's not like a SQL join, it's more of a set operation. So and is the intersection and or is the union. An example is provided. Typical queries can have modifiers to get passed on to Elasticsearch right now that will change the order in which the results are either displayed or processed, and also limit the number of results. So by default the limit is 10 for any search. You can change this using limit to exceed 10 or become less than 10. These are the standard indices. Resources index contains all of the resources, and then we just have various indexes for specific purposes, and then there's events index, which contains all of the Pion events, and searches and catalogs index contains metadata about the catalogs and indices. So here's a demo. So I got my container up now. I'm going to go ahead and make a few new platform devices here in the ocean off the coast of Rhode Island. Call this first. Second. Third. Fourth. So now I have these 4 platform devices. So if I click one of them, there they are. So now I'm going to create a search string that will actually search for these devices. But first I'm going to only search for this one. So what I'm going to do is I'm going to get the lat long at this point. Search. The field for their location is nominal location. Let's say 20 kilometers should do it. There it is. Just to make sure that that is the right one, this one should be third. There it is. So just go over some of this metadata real quick. The sort value, if you're using geodistance, is actually the distance to the center. And it's by default sorted by the distance. So if you have multiple documents within that, it's sorted by the distance from the center. The type, which is the index context type, not the actual type in the document. Although for this device's index, they are mapped directly to one another, but they may not always be that way. The index that the document comes from, and then the ID in Elasticsearch, which may not necessarily be the same ID in the data store, but typically it is for right now. And then the source, which is actually the deserialized ion object. Alright, so let me illustrate a bounding box. I get my top left. And my bottom right. Create my search string. And there's my 4 platform devices. First, second, third, fourth. And what we can do is we can even take that search string and add on some other stuff, like we'll change the order by name. So now it's first, fourth, second, and third. And then we'll go ahead and limit the actual results to 2. First and fourth. Alright, that pretty much sums it up.